All right, so graphing the polar equation r equals 4 sine theta, and taking a little bit of a tip from the last problem. Since theta seems to be the input, I'm going to start with theta values, and remembering that it wasn't enough to just do 0, pi over 2, pi, and 3 pi over 2, and so on, because the graph started repeating itself. Um, I'm going to leave a little bit of space there so we see what's happening. I'm going to make my columns accordingly. So when theta equals 0, I know that sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, which means if I multiply by 4, I get 0, 4, and 0. So this isn't a very interesting graph at all. When theta equals 0, I'm at the pole, or 0, 0. When theta equals pi over 2, which means I'm inclining pi over 2, and then I'm going out 4 units, so that means 1, 2, 3, 4. And then at theta equals pi, we are back at the origin again. So what is happening there? Well, as theta increases from 0 to pi over 2, we know that sine gains some ground too. And so we know that it's going to go outward before hitting that top point. I'm going to hit pi over 4, and I'm going to hit 3 pi over 4, because I know this is also root 2 over 2. And then if I multiply them by 4, I get 2 root 2 here and 2 root 2 here. So that's going to mean at an angle of pi over 4, now root 2 is about 1.4. So that means 2 root 2 is 2.8. So we're just under 3 there. So that's going to be 1, 2, 3. We're about right there. Which means if I go out to 3 pi over 4, I'm about right 1, 2, 3, just before 3. So there we go. And yeah, if you notice, if you connect all those points, we do have indeed a circle. Now, you would get there if you plugged enough points in. Naturally, another way to go about this is to write the equivalent equation in rectangular coordinates, and that would help verify that, yes, this indeed is a circle. So if I want to generalize, r equals a sine theta is going to have, again, a radius of a over 2, because notice, the diameter of the whole circle is 4, which means the radius is 2, and that means the center is at, well, if I do rectangular coordinates, the center would be 0, comma a over 2, but in polar, since that center is along the positive y-axis, r would be a over 2, and the angle would be pi over 2. Okay, so there's just a little bit about r equals a sine theta. In the previous video, we talked about a cosine theta. So as far as remembering special graphs, these might be important because, like I said, they have simple polar equations, which means we can get a lot out of them when we graph them. So thank you for watching. We're going to get into what happens when we have multiple angles in a moment. So thanks for watching. Stay tuned.